Brought to you by Connect.js, Atlanta's premier JavaScript conference. Sponsored in part by FeatherDirect. Need a mobile app? Contact us for your custom mobile solution.
My name is Chris Halaschek. In this session, we're going to talk about a JavaScript framework called Famous. I've titled the talk "The Future of the Mobile Web" with a question mark. So we'll kind of just explore sort of some newer things that have been happening around JavaScript frameworks for building applications and user experiences that can start to rival the things you can do in the native land if you're building native iOS or Android apps. So that's what we'll be talking about. Before I get started, who here has heard of Famous? Good, more hands than I thought. Who here has actually downloaded it and hacked on it? So 3 of you. And of the 3 of you, did you get very far? Did you get kind of stuck? It was okay? Okay, cool. So we'll talk about a little bit of history about just how things have gone with respect to trying to use kind of a web stack for building mobile apps. And then we'll talk about some of the problems we've hit, and then really just dig into Famous. So we'll do some introductory stuff, actually fire up Sublime and write a little code and build some examples. So hopefully that'll be helpful for everybody. So before we get started, let me log back in. So before we kind of dig in, let me just give you a little bit of background on myself. So I am an Atlanta native, but really just moved back in December. I spent some time up at the University of Maryland studying computer science, really digging into real-time data analytics. Then went out to San Francisco and ran 2 early-stage tech companies. I was out there for about 7 years. And then family reasons brought me back to the Southeast. So I'm now a resident of Atlanta again, which feels good. And I'm glad that this conference is happening here. I'm now the CTO of a startup called Voxa based up in Buckhead. So that's a little bit of my background. It spanned academic research and analytics to building web-based apps for about the past 15 years or so. So before we kind of dive into the state of affairs and really digging into Famous, I wanted to start with a little bit of history. I think this kind of helps set just perspective as to where we've been and where we're kind of going. And I'm going to orient this really around some of the most popular mobile platforms. And looks like the dates may be a little hard to read there, but on the far left we got 2007, on the far right 2014. So looking back, if we recall, the first iPhone was launched in 2007. I think probably all of us remember that. Most of us are probably using those kind of devices. So that was around the middle of 2007. And then later in the year, the first public working draft of HTML5 was released. It was actually in, I think, January of 2008. And one of the reasons why I like taking a step back and looking at this is, as I look back and was reflecting on this when I was putting together this slide, I had thought HTML5 was a little bit further along than it was when the first iPhone came out. So that was kind of a little bit of a refresher for me. So then what we saw was in kind of the middle, towards the end of 2008, the first Android device came out. And then following suit the following year, what we started to see was the JavaScript community was starting to explore how we could use a traditional web stack to build apps for the iPhone and Android. So that's when we saw PhoneGap come out. That's also when Accelerator released their first version of Titanium that would actually produce output that could be run on iOS and Android devices. So all that was happening in the 2009 timeframe. In the following year, we saw Sencha release Sencha Touch, which was kind of an integration and extension of EXT.js, which some of you may remember. And jQuery Mobile came out with their mobile framework. So what people were starting to explore was, well, how the hell can we make a web page look decent on these phones and you're opening up these smaller browsers, and how can we handle different device sizes and screen resolutions? So these frameworks are starting to emerge. In 2011, version 1.0 of WebGL came out. And then around this time, I think the debate started to happen about whether or not web apps or a web stack would be able to produce a user experience that would stay on par with what you could build with native iOS or native Android code bases. And that's when we were seeing articles in the news. And in 2012, the first candidate recommendation for HTML5 came out at the W3C, and then shortly thereafter there was this announcement by Facebook that they were going to abandon HTML5 and rebuild their iOS app from the ground up just using native components. And I think at least the way it was portrayed in the popular press was it was kind of an oh shit moment if you were a web developer. It was like, well crap, what are we going to do? People seem to be moving to these other platforms. And we saw articles like the one on Wired saying the web is dead and native's going to eat the web. So it was kind of a bit of a rough time during that kind of era, if you will. So we'll dive into why that was happening. But I want to point out that since then things have been continuing to move forward, and I've left a whole lot of things off this graph. You probably can't read the footnotes down on the bottom. The source is the internet, and this is horribly incomplete. So there's a lot of frameworks I've left off here, but the whole point is just to reflect on sort of the path that got us here. So if you kind of take a step back and think about what we are trying to accomplish, I can't really speak for everyone, but from my perspective, when we're building mobile apps, what we're trying to deliver now are really slick, seamless user interfaces that have, this is the Facebook Paper app, that have these beautiful transitions and kind of some three-dimensional effects that are really kind of silky smooth. I think this is just a good example of what you can do if you're, thinking through user experience and kind of taking animations to, to the next level, if you will. Here's another example, and this talk, the title was about mobile apps, but I kind of view this as just web development in general. So this is a site built by Complex.com during the World Cup, and I think we also want to start to explore more interactive kind of three-dimensional or 2.5D effects, even when building web apps. So this is a web app, this is iframed in, that they built, and they're using the notion of three-dimensional space to provide a richer user experience. So when I think about what do we want to deliver when we're building these types of applications, it's stuff like this. This is kind of what I think of as the future of where I hope we'll take applications just running on your web browser, but also apps in the app stores. So the question is, well, why has this been so painful to do using just JavaScript and HTML and CSS? Why did Facebook abandon that stack to go fully native? And I think it kind of comes down to two pretty simple things. I'm a fan of animated GIFs. A big one is just go faster. I think the components that Facebook was injecting using HTML and JavaScript just were not as performant as building them from the ground up using just the native components. So the scroll views, I think everyone probably remembers, were just sluggish and were not smooth. Related to this is make the app silky smooth. So no freaking jitter. You see a lot of apps that are clearly running kind of in, injected onto an iPhone or, running inside a PhoneGap or Cordova, and, you can tell that it is, a web app because it's jittery. So I think these are the two kind of core foundational problems that were, causing people to say, well, I just need to build it in iOS, Objective-C, and use native components. The question is, well, what can we do to kind of stay with our kind of happy path, which is let's use a web stack, let's use JavaScript, HTML, and CSS, and still deliver an application with this type of user experience that's silky smooth and fast. So we'll talk about what Famous does, but people have explored, well, let's just manually manage the DOM in such a way that we'll kind of work around the performance bottlenecks that you hit typically when just writing web apps and trying to do fancier animations. Let's keep it lean. Let's do CSS 3D transformations to do your animations. Avoid deeply nested CSS selectors. This all becomes just kind of hell for us. It's a pain in the ass to manage. Quite frankly, I went to grad school and studied CS, but I couldn't tell you a lot about 3D matrix transformations to move things around the screen. So it's just really, really painful. So what we've seen recently are people starting to build frameworks that kind of manage that for us. And Famous isn't the only one. We're going to talk just about Famous, but it's, there's other ones like React. React's doing something interesting with virtual DOM. If you look at 3JS, they're doing something similar to Famous as well. So there's a couple different directions, but what I wanted to really dive in today was Famous. So it sounded like most of you have heard of it. A little bit of history. So the guy who started PowerSet, Steve Newcomb, that sold to Microsoft, which is now Bing, he and another guy started Famous. They actually first started talking about the company publicly at TechCrunch Disrupt in 2012. And when they were up on stage getting interviewed, they demoed, it was some variant of this periodic table demo. And if you were like me watching this, my eyes kind of lit up. I was like, wow, that's actually really freaking cool. How are they doing that? And so what most people did when they browsed to the demo was you do your right click, and I expected to see Flash or some Unity 3D engine underneath the hoods. And what kind of blew people away was that when you inspected, this is all just DOM. So it's just a straight web stack, which is actually really freaking cool. So, this started to get a lot of hype in the press because of the smoothness of the animations and the transitions that they were able to deliver. So this is a really, really cool demo that they put together and allowed them to raise a lot of money just with this demo. A lot of cash. So what got people even more excited was that the promise of this was that it was going to be cross-device, meaning it's not just going to run in your web browser, but it's going to run on an iOS device, an Android device. It's going to run at 60 frames a second, so you're going to have really smooth kind of UI UX effects. And now it is open source. So this got people really, really excited. So question go. IE is a problem with Famous. So they're relying on some CSS3 stuff that I don't even know is fully supported in IE 11. So if you're a B2B company, we'll talk about this later. Like at Voxa, we don't use Famous internally because we have to service people using those browsers. So this was super, super hyped. They had about 100,000 people sign up for their kind of beta mailing list. When they then did a kind of public invite beta or rolling beta in April of this year, if you were like me, you probably got super frustrated because I was number 21,000 in line and they were accepting 1,000 people a month. So as a little side note, their marketing launch, which was super, super hyped, but kind of botched because a lot of people got pissed off because they were 70,005 in line. So anyway, they opened things up. What I want to talk about now is just kind of at a very, very high level what they've built. And then we'll go into some of the fundamentals, and then we'll actually do some live coding to actually build some stuff using Famous to see what it's capable of. So the two main things that the team has built there is a 3D layout engine and a 3D physics engine. Those are the two kind of high-level core components. And we're going to talk about each of those in a little bit of detail. So the 3D layout engine, what they've realized and what a lot of other people have realized is that the performance bottleneck is DOM, the way the browsers are calculating and doing layouts and writing to DOM. Reads and writes to DOM are just slowing things down. So they said, well, let's throw that away. Let's not let the browser figure out how to do the layout and the rendering. So what they did was they wrote their own layout engine that basically, if you basically, instead of manipulating DOM, you use what is called a Famous render tree, which we'll go into, and then Famous can process that and then figure out how to lay out the scene or the view or the app. And they basically reduce everything to matrix 3D transformations. So they're doing all that math for you. What's interesting about that is it's then hardware accelerated and the GPU does all the work. So the browser's not figuring out where to position things on the screen so much as more it's just the GPU that's doing it. So that's the first thing. That kind of addresses that first problem of go faster, which is one of the big challenges. So the second thing they did was build a full-blown 3D physics engine in JavaScript with the aim of trying to build more natural feeling animations and transitions. So if you look at a lot of mobile apps, or in particular gaming, they're all using physics engines for their transitions, their easing curves, and all their animations. And you can even have like full-blown simulations in a 3D environment. So they built this and then directly integrated it with the layout engine. So that's kind of addressing the go fast make it silky smooth, if you will. So that's at a high level. It's just the two kind of core components that they've built. Okay, so let's start to get our hands dirty and learn about how Famous works and talk about some fundamentals. So the first and most jarring thing, I think, for most web developers is this whole notion of forgetting about DOM. If you've built stuff using something like Unity 3D or 3JS, it's not as foreign a concept, but it's just a straight, like if you're just a jQuery developer, it is jarring to just abandon a lot of those things. So you are manipulating things in Famous just straight in JavaScript, and then they're managing the scene for you and rendering to actually DOM on your behalf. So you never really want to touch DOM. So what they give you instead of DOM is a Famous render tree. So this is the first kind of core component of Famous. Every tree starts with a root, and that root in Famous is called the Famous context. So if you're looking in HTML DOM land, this is like your body. So this is the root of your scene in Famous. And you always will create one of these. So in JavaScript, you just do engine.create after you've, in one way or another, included in their engine scripts, and that'll give you a context. So once you've got a context, you kind of have a scene that you can start rendering things to. So the next thing you may want to do is render something to it. So that brings us to the second core Famous component, which is a surface. So you can think of these things as the visual elements you're going to see on a screen, like an image or a div, a video. Those things would be constructed and added to your render tree by creating a surface. So you would instantiate a surface, then you can add it to your context. And in the abstract, if we're looking at the render tree, we're reading from top to bottom, we've added a child to the root node, which is our context. Does that make sense in abstract? Okay. We'll actually go in and build some of this, but just we're going to go through the high-level abstract concepts first. So this allows us to kind of render in a visual element. The next thing you may want to do is transform it in some way. You may want to rotate it. You may want to change its position. You may want to scale it up and down. So to do that, you use what are called modifiers in the Famous framework. And these are kind of akin to CSS 3 animations, if you will. So you could instantiate a modifier. If we look on the right-hand side, you can add the modifier to the context, and then you can add the surface. So this is a very, very important thing about Famous and the way render trees work. It reads from top to bottom. So you notice that we inserted the modifier conceptually and abstract in between the context and the surface. And that's because the modifiers will actually be applied to everything below it in the Famous render tree. So you can kind of think about this like in the DOM land where you have child nodes that may be positioned relative to their parent. That kind of propagates down as well in some sense. So that's what's actually happening here in Famous. So when I add the modifier to the context, what that returns is the concept of a render node. And then I can keep adding children to that. So you can kind of daisy chain these things together and make your tree deeper. Does that make sense? So you can take this a step further and actually create branches in your tree. So let's say for before in that previous example, our surface was an image, and our modifier was to rotate it 90 degrees about the y-axis. So it's just going to do something like this. What you can do is actually create branches in these trees and then apply higher level modifiers to different sub-branches. So you can have different effects on different portions of this render tree. So let's say, for example, modifier 1 was our 90-degree rotation, and let's say surface 2 was our original image. Well, using our render nodes that I can get a kind of a handle on, and I can then keep forking off of, I could add another modifier that may may translate or move by a certain number of pixels a different surface. So that surface would be not only rotated by 90 degrees, or 90 degrees, but also translated by whatever kind of number of units that we wanted. So what this will allow you to do is to kind of logically group together components, and we'll see this in an example, and then apply kind of UI effects or rotations or transformations on these logical encapsulations. So it allows you to build up more complex UI effects in your scene. Does that make sense? I'm seeing some nods. So this is all abstract. Let's let's actually make something. I think the best way to learn any framework is to just fire it up and start building something. So here we have a square that's centered, that's blue, that happens to be 200 pixels by 200 pixels. So what I want us to do is go in and just build this in Famous. I can point you guys at the end to this. There's a GitHub repository with the collection of these examples that we'll walk through. And you can get started with Famous in a couple different ways. You can download their starter kit. They also have Yeoman generators. This project structure was built using their out-of-the-box Yeoman generator. This uses Grunt in Require.js. If you don't know that, don't worry about it. Just kind of overlook it. The main thing we're really worried about, one is I have some simple CSS with some color gradients, and then we have, the main kind of script that's going to boot up our app. So this is just imported using Require.js and built with Grunt. So what we've done here, again, this should look kind of familiar given the slides we went through. We're we're getting a handle on the Famous engine. We're creating a context. We're setting the perspective. Don't really worry about that. This is setting up kind of the 3D space. So what we want to do is create a square. So how are we going to do that? We're going to use surfaces. So remember, surfaces are what give us the visual elements on the screen. So I'm going to include in the surface class if I can type. And we will go ahead and create a new surface. Okay, so surfaces, like all the other kind of core elements in Famous, they'll take an options hash and, into the constructor so you can kind of tune it. So what we want to do with this surface, we said we wanted to make it a 200 pixel by 200 pixel square. So Famous surfaces, if it's just the default Famous surface, it's really just going to create a div, is what it ends up injecting into the scene. So that'll produce our square. I just happen to know that. One of the options that it takes in is a size, and this is in pixel units, and it'll take in an x and a y size, so width and height. So I can just say 200 by 200. So that's going to create, or tell the Famous rendering engine to create a surface of size 200 by 200. So that's going to be our square. Other options that we could pass in directly CSS attributes by this properties hash. Alternatively, we can pass in an array of CSS classes. So I happen to have a blue background class, which was defined in my CSS file. So what we've done is we have, unless I have typos, created a surface. So if I go over to this page and refresh, I don't see anything. And the reason is because we haven't added it to the context. So that when Famous goes and lays out the scene, it's going to look at the context, look at that render tree that's been constructed, and then lay it out. So what we need to do is come in and say main context.add surface. If we refresh, fantastic. We got a square. It's blue. If I right-click on it, we'll see what Famous did. So when we create a context, what Famous will do is just inject a new div and assign a certain class to it, the Famous container. This surface happens to be another div. You can see it's got my blue background class. They've hard-coded the width and height. And then they've got some matrix 3D transformation in here for positioning. So that's really all they did underneath the hoods. So we said we want to center this thing, right? So instead of going in and maybe doing some margin setting to try to make it center, we're going to use what Famous provides us, which are Famous modifiers. So if we come back over to our app, I'm going to import in the modifier class. Okay, so we're going to create a modifier and add it to the render tree to perform that translation for us. It's really what we're doing, is we're moving the thing. So we're going to say modifier, equals new modifier, and we have yet another options hash. So when you create these modifiers, for positioning, you want to specify two attributes. The alignment, and I'm going to leave that blank for a second, and the origin. So when we look at this scene, the way this works is that the containing element for the square is the entire viewport, it's the entire browser. So we're going to use the modifier to say, well, we want to align this differently relative to this entire viewport. So think about that like centering or whatever. So with the alignment, we can come in and say the default alignment is the top left corner, which is 0, 0. It's on a 0 to 1 scale. So if I wanted to center align it, I could say 0.5, 0.5. And if I comment that out, this should work. The next thing we want to do, recall I said that the tree reads from top to bottom. So if we want the modifier to be applied to the surface, it needs to be injected before the surface. So I'm just going to daisy chain these things together. Refresh. And what went wrong? Say again? Line 23. Oh.
Line 22, modifier.
Thank you. Thank you. I'll actually correct the spelling. There we go. There we go. Okay. Thank you for the catch. So if we notice something, the thing is now its alignment is actually relative to the center of the screen. The thing is, though, it's not really centered. And why is that? So by default, the origin of the surfaces is going to again be the top left. So it's aligning relative to the origin of that surface. So we can use the origin attribute to adjust that. So if I come in, if I set the origin to 0.5, what's going to happen? It moves it to the center. So we're just using modifiers to move the surface around. Really, really simple. Okay? Now, if you're like me, when I first looked at this, I was like, holy shit, there's a lot of code just to center a square on the screen. What we'll notice is it becomes very easy to start doing additional things to this that would require a lot more code if you were kind of hand rolling this. Okay, so back to our example, or to our slide deck rather. Okay, so we've used a modifier to kind of set the origin and alignment. The next thing we can also do is use the notion of transforms. So this is another kind of core component in Famous, or transforms. These are going to be linked up to our modifier, and they will be used to transform the elements. So what the transform attribute actually takes in, it's a 3D matrix, and Famous is going to use that to go and position the elements and transform them. So let's say we wanted to move this square by 100 pixels along the x-axis and 200 pixels along the y-axis. We could add this to our modifier, and we're going to get something like this. So if we go back over to our code, this is super simple. I'm going to need to import my transform class. Yeah, this is the problem with doing this live. So there we go. We've moved our square. If I reload. Sorry, over here. So if I were to adjust these values, this guy's just going to move around. So we're just using transforms to move elements about the screen. Okay? Super simple. So the way that Famous's rendering loop works is it's executing at 60 frames a second. So their rendering algorithm is just looping at that frame rate. And it is going to inspect everything that should be rendered on the screen and reevaluate the actual position at that particular iteration in the rendering. So if we looked at the previous example, our transform was just basically the same value we're returning all the time. What you can actually do, though, is pass in a function that can return a different transformation, and then that will be taken into account at a rate of 60 frames a second. So let's say we wanted to take that square and rotate it about the y-axis. So we're going to have a spinning square. Well, what we could do is set an initial angle and then increment that angle. This is going to be at a frame rate of 60 frames a second. That's going to be continuously increasing. And then I could use that angle to just set the y rotation. Okay? One thing to note in Famous, rotations, like some of these other 3D frameworks, are in radians. So it's a little thing to note. If you want to work in degrees, it's pretty simple math to translate between the two. So if we were to do something like this, what we're going to end up getting is a square rotating about the y-axis in three-dimensional space. So let's go back to our code and do something like that. This will be the last thing I live code, and then we'll just start checking out branches. Because you guys can already see that I'm prone to typos. So we'll just come in here, function. Okay, so what are we doing? We're basically going to continue bumping this angle. At each tick in the rendering, it's going to say, okay, relative to the initial position or the initial origin of this surface, where should I be now? It's just going to be slowly increasing it over time. So it's going to just have this rotational effect. If we go over, look at our demo now. Okay, what's happening here? I see it, now I don't. I see it, now I don't. So the default rendering or interpretation of CSS is that the back face of these elements are not visible. So it's rotating in 3D space. So there's a little CSS command we can do to set the back face visible. That looks like something like this. I'm just going to copy this guy over, just setting back face visibility to visible. And there we go. Now we're going to have a two-sided square rotating in 3D space. Any questions so far? I'm sorry? For what? That would be, you'd have to have two different surfaces. So that would be a little bit more complicated. Yeah. And there are, we'll comment on this in a bit, there's some out-of-the-box components for doing easy flippers with two-sided kind of effects, which is what you were seeing in, similar to that demo I showed you with the soccer ball in the FIFA example. So there's some easier ways to do that. Okay, so let's go back to the presentation. So if you think about what we were kind of just doing there, we were in some sense maintaining a notion of state through time for that particular element. One way to do it is like we did before. We had this global variable angle and we were just incrementing it. Famous does make that a little easier in a couple different ways. There's a notion of transitionables that will, given a duration in an easing curve, will kind of transition a variable from 0 to 1. And so then you can use that to help maintain that state. There's also additional types of modifiers that will make this much easier to do. So there's a kind of a subclass of a modifier, which is a state modifier. What you can pass into this additionally is a duration in an easing curve. And they have a whole suite of different easing curves that you could select from. So what that could then allow us to do, in this example, let's say we wanted to rotate about the y-axis by 1,000 radians. Over a duration of 500 milliseconds with this particular curve, and then after that's done, rotate back to the origin or 0, you could do something like this. So with the state modifiers, the way this will be executed is the first one will execute, and then it kind of buffers them up, and then the second one will execute once the first one's executed. So that's just done by calling set transform one after the next. So what would that do? It'd give us something like this. So we're just flipping it back and then bringing it back forward. So you can imagine things like button click effects where you could start to do those types of animations using something like this. So let's go and I'll just show you that in code so you can just see how that works. What I am going to do is just check out a branch with that. So if we go and change tabs here, we've got this kicking off. So let's go look at the code real quick. A couple quick changes that we made here. Instead of importing in a modifier, we're importing in a state modifier. And then what else did we do? Not much else is different. The square or surface is the same. I called it square apparently here. And then we're just having state modifier set transform rotate by 1,000 radians over that duration with that curve. Afterwards, rotate back to 0 over 3 seconds with that curve. So again, that produces this effect if I refresh. So if we wanted to say rotate further, we can just change our radians there. It's going to go further back. Again, it will happen over that same duration. So Famous is kind of managing all that for us. That make sense? Okay, cool. So I mentioned that Famous has a physics engine. So you can create, custom kind of instantiations of this physics engine and create particles and colliders and, impose forces like gravity and do all that kind of stuff. They also expose it in kind of prepackaged ways that make it a little easier to apply for like UI effects. So what we could do is use what they call a spring transition. So it's going to be a spring effect that's going to be simulated using the physics engine. And then we can use that for those transformations that we were just doing before. So in this example, we'd use a spring transition. You could set the damping ratio, which is just going to kind of slow the oscillation with some degree, and then it'll execute over a certain period. So what that's going to do is give us an effect like this. So again, the way these things are reacting, that's just going to be driven by the underlying physics engine. So let's go ahead and check this out. I will just check out this branch, square physics. All right, so if we refresh, we're going to go back. Oops, wrong tab. I'm going to refresh, and there's our effect. It springs back, comes back. So what's cool is we could come in here, and again, here's what I did. I imported in the spring transition. Our other setup's the same. Here's our state modifiers with the same kind of commands we had before, but now we're using the spring transition with the period and the damping ratio, same stuff I had on the slide. So then what we can do, you notice the damping ratio we're using here. Well, if I wanted, you can start to tweak these things. So I could reduce it, so that means it's going to spring longer. So you can just see it's springing more. So the nice thing about this is you can kind of tune the effects, you know, kind of however you want, and it's all going to be then simulated using their physics engine. Does that make sense? Any questions? Okay. All right. So those are kind of primitive components. You know, if you're going to build a complicated app, you're going to want to, you know, encapsulate things together. So in Famous, there's this notion of a view, which kind of makes it easy to do that. You can add surfaces, modifiers, other views to views. They also provide some out-of-the-box views that you can use to build apps. So they have a scroll view, which is, you know, imagine like a Twitter feed, where you just add elements to them. They have a header-footer layout, so if you're building a typical kind of mobile app or web app, you can use that to kind of get started with that structure. There's a grid layout. You can also build your own custom layouts. So what I wanted us to do was to take what we've kind of learned with our square and turn it into something like this, where we're going to use a custom view to make a cube, and then we're going to apply a modifier to that cube to produce the rotational effects. So this is just rotating about the x and y axis in 3D space. Okay? So if we go back over to our code, here's our tab. Check out our cube repository. Okay, so we have a working example. So let's go look at the code and see what's actually going on. Okay, so we've got a cube class. This is going to be a view. We'll look at that in just a second. We've also got our top level modifier. So again, if you think about the render tree, any modifier above other nodes will be kind of applied down the tree. So what we're going to do here with this example is we're going to have a cube object at the bottom of the render tree, more or less, and then above it we're going to have a rotational modifier. So then that modifier is going to be applied to all of the surfaces of the cube, and that's going to rotate the whole thing in unison. So that's what this rotate modifier is. If I come in and comment out our transform, you're going to see we just have this cube in 3D space. I set the opacity on the surfaces so you can, and set a little border so you can actually see it somewhat in 3D space. So all we're doing is we've got this rotate modifier. We create our cube. We add the modifier to the root context, and immediately below that we add the cube. Okay, so let's dig into the cubes. That's the real meat. Okay, so this is just using prototypes to create the class in JavaScript. We're all very familiar with that. So we have our cube function. It is going to use the view class. We passed in our little options with the size. So this is just going to be the size of the different faces of the cube. So it's going to be 200 by 200. You know, again, just pretty standard inheritance with JavaScript. Really all the meat's done in the init surfaces method down here. Okay. So if you think about a cube, what's a cube? It's just 6 faces that are rotated and translated in a certain way to produce the cube. So if you have a 200 pixel by 200 pixel kind of cube face, what you're going to do if you want to position the rightmost face is rotate it by 90 degrees and then translate it half the width of the cube. So in our case, 100 pixels. Then you're going to do that for all the other elements. So the way we've built this here is we've got an array of rotations. One rotation, this is X, Y, and Z. So this is going to be one of the rotations applied to one of the cube faces. So just to compact it, we've just thrown it into the surface rotations array. Notice I like to work in degrees, not radians. So I'm converting 90 degrees to radians. You know, the math is, again, pretty simple. Just consult your unit circle. So the rotation for this face is nothing. It's not going to do anything to it. It's going to be the front face. It's either the front or the back face. I don't remember which one it is. But that one doesn't need to be rotated at all. If you look down, I believe this is the right face. So it's going to rotate along the y-axis by 90 degrees. So that's going to be your right face. And you set that up for the other ones. So then what else do we need to do? We need to translate them. As I mentioned, we have a 200 pixel by 200 pixel cube. So we're going to move them by 100 pixels in a certain direction. So the front face, we're moving along the z-axis by 100 pixels. Move it up. There's going to be a back face right here that's going to move it back. So we're just translating those surfaces to construct the cube. I suspect eventually, Famous is still a new platform. I imagine like 3JS will start to have some primitives where you won't have to do this manually, but right now we're kind of doing it, kind of hand rolling it. Okay, so now we've got the necessary rotations and translations. So what are we going to do? We're just going to go through a little loop here and add these things to the view. So the view exposes an add method similar to the all the other render nodes. So what we're going to do, again, I said I wanted to set the opacity to make it semi-transparent. So you can set an opacity attribute on a modifier, so it's going to just make everything have an opacity of 0.8. We're going to instantiate our translation modifier. We're going to instantiate the rotation modifier. We have our same surfaces before, no different. And then I'm going to add them to the view. So I'm going to daisy chain these together. What it's going to do is create off the kind of the view render node 6 branches, one for each basic surface that's going to have off of the view element or view node. First an opacity modifier, followed by the translation modifier, followed by the rotation modifier, followed by the surface. So it's going to position each individual surface as it should to form the cube. Yes?
Does each surface need to instantiate that opacity modifier? Like, could you reuse a modifier?
Well, one thing you could do is include all of these things in one modifier. So the modifiers, you can actually, again, it's just matrices, so you can multiply them through and then have a composite kind of matrix. So that's what you'd actually want to do in that case. As far as modifier reuse, honestly, I'd need to look. Yeah. But if I were writing this, I'd actually compact them all into one modifier. I'd have a single transform function and then include the opacity, and then I'd just do a transform out multi. So they even provide you the multiplication kind of hook, if you will, and then you could apply the translation and the transform in one matrix. Okay, so what we then get is our cube structure. So when we are back in our main class, we've instantiated the cube. The cube's a view, or subclass is view, so it's a renderable, which means I can add it to the famous render tree. So I can just do a dot add. So I'm first going to apply the rotate modifier to the cube, or I'm sorry, to the render tree, and then add the cube. So we could come in here, and if we wanted to speed things up, we can make things go faster just by bumping our angle. If I want to make the cube bigger, there you go. So these things are all kind of tunable. Yeah. Yes, you can. There are set size methods, and you can adjust the modifiers kind of on the fly as well. So you can do a set transform and change things. Yeah. So, if I were going to do what you were just saying, if I wanted to stay true to the famous approach, which is not to really touch DOM, I'd create another surface, which would be my button. They have out-of-the-box famous buttons. And then you can add event listeners, and then you could trigger that stuff. Yep. Okay. Any other questions? Yeah. I mean, so it's basically the animation. Request animation frame is what they're doing. So it is in that main loop. Yeah. I mean, they're just straight JavaScript. So they're not really. There's no additional libraries they're using or anything. Yeah. Yep.
You said that those are all divs.
Yep.
HTML?
Yes. So Surface is, if you're thinking about the way they kind of suggest you do this stuff is anything you want to apply like fancy animations to. So imagine you had like, we could go back to that example. Basically anything that's kind of static content that's HTML that isn't really going to change, you can just inject into a surface. So in a surface you can set content, which could be just any old HTML, and then that's just going to be just straight DOM and rendered as usual. So you would apply CSS classes and style it however you wanted. So for example, this entire presentation is built using Backbone and Famous. So most of the views, most of these screens, this is a surface here, and I just, sorry, triggered a click there. This is just straight HTML for the content. And I'm just letting Famous render it into a surface, and I'm applying just straight up CSS styling to actually get font size, color, and all that stuff. So yes, yeah.
Now you're showing us a lot of 3D capabilities, but Famous's orientation is not specifically 3D. I mean, it's very much, it's primarily a 2D thing, isn't it?
It's either. I mean, so they're, for all positioning, they're using matrix 3D transform. So you can just do it in 2D space, or you can do it in 3D space. So it's there to use.
And the orientation is mobile, right? It's not really intended for websites.
So it's just a JavaScript framework. I don't really build mobile apps, and I've got side projects that aren't mobile first, and I'm using Famous for those. So it's not, I mean, they have kind of initially when they launched it said it is intended in it, for mobile app development, because their kind of goal was to just try to use standard web stack that could build experiences that rival what you can build on native. But I mean, it's not really. It doesn't dictate that you have to be building a mobile app versus just a desktop web app. It doesn't really matter.
Do you know the compatibility on mobile devices?
Yeah. So iOS and Android coverage is good. So all these things will run at 60 frames a second on modern iOS and modern Android devices.
Back to like iPhone 3GS or not?
They've run on even an iPad 1 and in the older iPhone devices. With newer versions of the framework, they're still hitting that type of frame rate. Now, you can do crazy stuff that will degrade the performance. So, I mean, you still need to be cognizant of what you're doing. But if you use the framework the way they are intending you to, you can actually get really good performance.
So on that idea, this is 60 frames a second. So does that mean that all the code I'm writing is executed at once?
Yeah.
Like
Not all the code. So if you look at like a modifier, the layout engine is going to inspect that modifier at a rate of 60 frames a second. They're going to recalculate where it should be positioned. I know they're working on right now. If you noticed, these things are continuously updating. They're working on a system of kind of dirty checking, so they won't relay out elements that haven't been moved. Yeah, something like that. Yeah. But yeah, I mean, the event loop's going to go at 60 frames a second. It's going to look at like the transforms, reposition things. Yeah. Mm-hmm.
So I'm just trying to truly understand this use case, like web applications without a lot of crazy 3D stuff. You're still saying, like, what would be the true, like, apples to apples advantage of basically creating a surface for everything? Essentially, you're saying don't use the DOM anymore. What would you get out of that taking like a mobile web application?
I think I'll address that with some examples in a minute or two. I mean, I think there's a trade-off. And this isn't intended for any web app you're going to go build. So if you don't have if it's a static web app and you don't really care about animations or any kind of 3D effects, I wouldn't trouble yourself, to be honest. If you're trying to build a mobile game or build a very, kind of modern mobile app with very sexy kind of transitions, animations, this could be a good alternative if you're wanting to use JavaScript in a web stack, if you don't want to go and write native. So it's going to, I mean, my kind of mantra is use the right tool for the job. It's not the right tool for every job. But let me come back in just a slide or two, and I'll point out a couple things that will kind of illustrate, I think, some of that. Okay, so a couple other things. I said there's a full-blown physics engine. You can do lots of interesting things with that. This is just things we don't have time to go into. They have their own eventing system. For performance reasons, they tell you not to use just regular DOM events, but to use the famous events that are emitted. Importantly, famous is just the V in your typical MV star framework, MV whatever framework. So, it's not, you're not just going to go use famous and then get routing and controllers and all that stuff. So they have bridges and integrations with, they're working on Ember. The Angular one is actually pretty robust. Backbone, it's actually pretty trivial because you just, instead of using Backbone views, you're going to just kind of use famous for your kind of view portion of your Backbone app. So that stuff's all there. So to answer your question a little bit more directly, oh my God, why the hell do I care? Well, if we go back and look at some examples, if you're doing gaming, I think it's, this is a pretty compelling option. Same thing with like 3JS. I think it's another really interesting thing out there. But I mean, if you're looking to build these types of interactive elements, again, this is all just DOM. This type of stuff can be done in a performant manner using famous. Here's another example that's kind of an extension of what we were doing. I think I skipped one. This is an extension of what we were doing with our kind of cubes. I mean, again, kind of 3D immersive visual elements. This paper app I showed you is actually built entirely in Famous. So they recreated the paper interface using Famous. So all those animations that you're seeing in here, it's all straight JavaScript, HTML, and CSS3. So if you're trying to build that type of UI and that UX for mobile, it's going to be pretty hard to do. It makes it a little easier to do. So if you're building that kind of app with these types of transitions, Famous could be something to consider. I mean, that's what kind of got me interested in it. That's mobile. Guess what? This other example I showed you, this is also all done in Famous, so this is on the web. So I mean, again, I think it's sort of portable in that respect. This was really cool. The code to do this is complicated, but the effect is compelling, I think. So again, that's done with Famous. So, I think it just depends on the use case, what you're trying to accomplish. And if it's a good fit, great. If not, use something else. So when would you want to use it? Again, like I said, if you're building a single page app, that's one thing. If you're doing 3D work, I think it's a good potential fit. If you're doing mobile development work, interactive mobile development work, and you're a web guy or girl, it could be a good fit. So there are some cautions, though. It is still very new. They just launched, I think, 0.3, so there's going to be backward incompatible versions. So it's something. There are still some device quirks. One that people complain about a lot is something with the Android keyboard. IE support is supposedly they're going to be doing something for it, but it's still pretty limited. We mentioned the Just V and MVC. There's also startup risk. So the company, supporting Famous right now is a very well-funded San Francisco startup, but there is that risk about community, although it's pretty active right now. Some resources. You've got Famous University, which is an online interactive kind of tutorials, which is really cool. They've done a great job with that. The IRC channel is very active. So if you go to Famous on Freenode, we had an intern in this summer. We just said, go learn Famous and teach it to us, see what you can build. And he got a lot of great support through just the IRC channel. Famous blog has a lot of stuff. And the ATL Famous meetup, which first meetup was this past Tuesday. You guys, if you're local, come check it out. So, I don't really have a crystal ball. I don't know if Famous is gonna, how long it'll be around. What I will say is that, their approach, I think, in at least the near term, or approach like that, will help us build more immersive kind of web apps and mobile apps that can actually start to rival things you could do in native. I don't know that it's going to be famous. Maybe it's 3JS, but that whole, intelligently managing the way DOM is rendered and the way things are positioned, I think is something, that makes it special. And I think that will be the approach in the near term until at least the browsers catch up. The other thing I really do think is that, users will continue to expect these more interactive, high fidelity, rich application experiences. So, I just encourage all of you to look at these types of frameworks like Famous or 3JS, Scene.js. There's a handful of them out there that make it easier to build those types of applications. So I'd say go check it out. And that's all I've got. So this slide deck is up on my GitHub page. Sorry for the small font. It's the same as my Twitter handle. So see halaschek.github.io/famousconnectjs. The examples are up in a separate repository as well, so you can just look at the different branches if you want to play around with it. So that's all I've got. I think I've got 3 minutes. If you guys have any more questions, I'd be happy to answer them. Yes?
How do you go about testing this?
So testing is hard right now. And they do say they're going to be coming out with a test framework that will make it easier to actually do that. Right now, it's going to be tricky. Yeah. In general, web app testing is tricky, but it's going to be a little tricky, yeah. Yes? Sorry, can you speak up just a little bit?
How difficult would it be to render like a sphere or toroid?
Yeah, so, the whole notion of like rendering a bunch of polygons to generate a sphere, they're not really supporting that quite yet. You're still kind of, at least in this, you're rendering to DOM. They're working on renderers to WebGL and Canvas, in which case it'll be easier to do that. So that stuff's coming. Right now it's difficult. So a framework like 3JS is going to make that much easier. But in future releases, I think it'll get there. Because I think later this month they're doing a big demo release of their renderer for WebGL, and once you're in that space, it's easier. Anyone else? Yep.
So, how is that like? So you mentioned this tools of suites and game development, but I think I don't know much about it, but I think there are better frameworks for game development, right?
For game development? Yeah, Unity 3D is awesome. The Unreal Engine's awesome too, yeah.
So probably you use this for that, right? This is more for layout.
You could use Famous for doing game development if you wanted to run it in a web browser, not have to have plugins like the Unity plugin in the browser. It'd be an option.
And also, how does the effect of better line?
I think it depends on what you're doing, how active the animations are. That's always a moving target. If you have constant running, really rich 3D transformations always happening at 60 frames a second, like most games, it will start to drain your battery.
So let's say you go to such an ad, but at that moment there is no animation. It will still call these certain random functions.
Yeah, at that point it should be no worse than than just it's just the web page sitting there. Yeah. Okay, so I think we're out of time. So thank you everyone, and I'd say go check it out. It's fun to play with.